One thing to remember, if we look at like problems like number 3, when we have 0, we get 0 over a number, that's going to give us 0. So if we have, for limits, if our limit equals 0 over a number, that means our answer is just going to be 0. But if our limit comes out to be a number over 0, what is that going to be? Undefined or does not exist. Or we could even write infinity, right? Because we have a really large number on top, bottom is approaching 0. Our overall value is getting larger and larger, so it's approaching infinity. So these are things to remember when we're doing limits. Let's go ahead and take a look at number 7. So here, limit as x approaches infinity. So limit as x approaches infinity of x squared over natural log of x. If we put infinity in here, we're approaching infinity on the top and the bottom. And one easy way to kind of look at that is look at the pictures or look at the graphs or think of the graphs. If we thought of y equals x squared, we know that's just going to be a parabola. So as x approaches infinity, as we keep going further and further to right, the y value keeps going up and up. So that's approaching infinity as well. Y equals natural log of x. That graph looks like this. And as we go to the right, the graph keeps going up. There's no horizontal asymptote. It's not like leveling off anywhere. It's going to keep increasing. It doesn't increase as quickly as this does, but it's still increasing and going towards infinity. So if we get infinity over infinity, that is one of those indeterminate forms. We can use L'Hopital's rule. We're going to take the derivative of the top. We get 2x. Over the derivative of the bottom, natural log of x, derivative of that is 1 over x. Now if we reevaluate, if we put infinity in here, or think about this graph, y equals 2x, right, that's going to be increasing. That's going to be infinity. Over here, 1 over x, so the bottom's going to be approaching infinity. What's 1 over infinity approaching? Something we talked about back when we learned about limits. Let's think about it. If it was like 1 over 10, we've got 1/10. Let's say then 1 over 100, 1/100th, 1 over 1,000, 1 over 10,000, 1 over 1,000,000. What is that number getting closer and closer to? 0, right? So if we're going on top, infinity, bottom, 0, this is approaching infinity, or we can say it does not exist. You can write either of these. You don't have to write both. The limit does not exist, or it's approaching infinity. But for this part, this is something we need to remember from before. If we have the limit as x approaches infinity of 1 over x to the n, and n is greater than 0, so as long as that exponent's positive, that's going to be equal to 0. Right, because that bottom number is going to get larger and larger, but when we do 1 divided by that really big number, it's going to get smaller and smaller. It's going to be closer and closer to 0. So something to remember from the beginning of limits.